Geometry, Unit 1, Lesson 4. I can use algebra to solve problems involving the segment addition postulate and the definition of a bisector. So a segment, we know, looks like this with endpoints. Addition means to add. And postulate is a little bit of a fancy word. Postulate is a rule we accept without proof. That's really important. A rule we accept without proof. So, if you take a look here, if we have point B, let's say, between points A and C, then we know if you add up the distance from A to B and the distance from B to C, you should get the distance from A to C. Let's get a picture of that to really understand what's going on. So here I'm going to sketch a picture. I'm going to call this A and C. And it said point B is somewhere in between. How about right here? And so what it's trying to say is if you take the distance from A to B and you were to add that to the distance from B to C, what would you get? Well, the distance all the way A to C. So you got this little segment here plus this segment here. It equals the big segment. If you add one piece to another piece, you get a bigger piece. Okay, makes sense. But let's talk about for a moment how we say this. This here is different than this here. When you see the bar, you speak the bar as the word segment. Segment AB. It's the name of it. But if I have the A and B without the bar, you actually speak it as the measure of AB, or the distance from A to B. And that has a number answer to it, right? Maybe it's 2 inches, who knows? So again, with the bar you say segment, it's the name. Without the bar, it means the distance from A to B. Okay. Let's go ahead down here and take a look at some examples. What's the goal here? We're going to use geometric notation. So we need to make sure we're using things like this bar or without the bar. And then we're going to go ahead and use substitution to solve for a missing measure. So let's say that the thing we're trying to find is the distance from B to H. Okay, this is what I'm looking for. And so I can see, if I'm going to go with the notation, this is what I mean. The distance from B to M plus the distance from M to H equals what I'm looking for, the distance all the way from B to H. If I were to think about this with highlighters, this segment here, if I were to add it to this next segment, I get the complete segment BH, the segment addition postulate. So now I'm going to go ahead and substitute. So instead of the distance from B to M, I'm going to put 5, because that's how long it is. And I'm going to put 3 for the distance from M to H. So finally, the distance from B to H overall is equal to 8, and in this case, centimeters. Now you can go ahead and hit pause and try the next one. Do the same thing with notation and substitution. And let's let what we're trying to find here be the distance from L to T. Okay, so if you hit play now, this is what I'm looking for. If I go with the notation, the distance from L to G plus the distance from G to T is equal to the whole distance from L to T. This distance here plus this little distance here is equal to the full distance from L all the way to T. Let's go ahead and substitute 13 plus 4, and I should have 17 feet for the distance from L to T. Now we're going to do the same thing down here, but you'll see it gets switched up a little bit. Let me make my find. In this case, the distance from V to S, this down here. So I'm still going to go with the same idea. The distance from V to S plus the distance from S to W is equal to the full distance from V to W. And if I was to color code, gotta love the highlighters, they help make things clear. The pink segment plus the yellow is equal to the full segment. Segment addition postulate. Now let's substitute. I don't know what the distance from V to S is, so I'm going to leave it like that. This distance I know is 8, and the entire distance I know is 13. Once I get this relationship set up, now it's just algebra. I want to solve for the distance from V to S, so I'm going to take away 8 from both sides to undo the addition. And what I'm left with is just 5. In this case, it's 5 inches. I'll bring in the units at the end. Did I really find what I'm looking for? Yes. You can hit pause and try the next one yourself. Let your find, in this case, be the distance from Z to B. All right, if you're hitting play, you're looking for the distance from Z to B. I'm going to go ahead and start with my notation. Distance from P to Z plus the distance from Z to B is equal to the overall distance from P to B. And you might be wondering, why do I keep saying the distance from, Because that's literally how I read this. You're supposed to say the distance from P to Z. If I put a bar, I would say segment PZ. That's not what I'm naming. I don't want to name things or notate them now. I want to talk about how long they are. That's why there's no bar. So this segment here plus this segment here is equal to the full segment. This segment I know is 7.5 units long. This one, I don't know. So I'll just keep calling it the distance from Z to B, and the full distance is 26 units. Notice there's no units, so we can just put units at the end. I'm going to use my algebra, take away 7.5 from both sides. If you need any scratch work, go off to the side to do your scratch work. Let me see if I do that. That's going to be 18 and 5/10 units. There we go. So now, if we turn, we have a few more things to talk about. Here are 3 new words. Congruent. There's a symbol for congruent. And the symbol that we're going to use in this case looks like an equal sign, but there's a trick to it. There's a single squiggly sign on top. You speak this out loud. Congruent. And congruent, think about identical twins. They're equal in measure or shape. Exactly the same. Midpoint is the middle. It's halfway. So, for example, if B is the midpoint, you know that this segment here and this segment here are exactly the same. Or a better word, congruent. Finally, bisect, look at the prefix. Bisect means, well, bi means 2. I think of sect like section, so to cut something into 2 sections. Divide something into 2 equal parts. Okay, so not just 2 sections, but 2 equal sections, or 2 equal parts. So let's go ahead and take a look over here. If I want to notate that 2 segments, or really 2 of anything, are congruent, I can put what's called a tick mark on each one. So segment AB and segment BC are congruent to each other. One way I could write that would look like this. Segment AB is congruent to segment BC. And if I were to write a sentence describing this, I might go ahead and say that segment AB is congruent to segment BC. And I'm trying to use all my vocab. Because point B bisects segment AC, which is the whole thing. So point B is a bisector, cuts it in half to 2 equal pieces. Okay, it bisects AC as its midpoint. It's the middle point. And you can see here I worked hard to get in all 3 of my vocab words, and in this case they are congruent, bisects, and midpoint. So how does this play into what we're going to do down below? let's go over some examples. Find the measure of the distance from n to v. Okay, I'm going to find this. It's really important. I'm going to put stars around it. It's so important to me that I find the right thing. Now it says point R is the midpoint, and I can't stress this part enough. This is a very important word, because what that allows me to do is put a tick mark here and a tick mark here. Again, what does this mean? Midpoint, I'm going to annotate, means that these two pieces are equal. So if this is 11, I can label this segment 11. And if I were to write some notation, I might say this. The distance from n to r is actually going to be equal to the distance from r to v. In other words, hey, 11 is equal to 11. But what am I really trying to find? The distance from n to v, all the way. So if that's what I'm really trying to do, these three dots right here mean the word therefore. I can say that the distance from n all the way to v is equal to the distance from n to r plus the distance from r to v. In other words, 11 plus 11. So the distance from n to v is 22, and in this case, feet. You can hit pause and try the next one. All right, here I go. I'm looking for x. So I'm going to circle that, put some stars around it. Not done until I find it. And so now I notice again that the midpoint of segment AC is B. That's really important again. These are congruent segments. I can put the tick marks. I'm even going to annotate. I care so much about that word. Midpoint allows me to put these two tick marks here. So then what's the relationship? Well, segment AB is actually equal to segment BC. Excuse me, I said segment. I should say the distance from A to B is equal to the distance from B to C. So now I can substitute 4x minus 5 is equal to 2x plus 11. And now I let my algebra take over. I'm going to add 5 to both sides here to undo the minus 5. And then I'll divide both sides by 2. And finally, I'm going to get x is equal to 8. Is that what I'm looking for? Yep, so I'm good to go. You can hit pause and try the last one. Okay, here I go. Point Q is the midpoint of segment NT. Ooh, that's a big deal again. But I don't have a picture. So besides finding what you're trying to find and always circling it, the second rule is if you don't get a picture, you better sketch one. So I'm going to go ahead and sketch a picture over here. I'm going to sketch segment NT, and Q is the midpoint. Okay, so again, if it's the midpoint, I can put my tick marks down. It's really important to me. And now, once I get a picture, I also like to annotate it. So I'm going to put this information, 2x plus 3 on the distance from N to Q, and 6 minus 4x here. That's the distance from T to Q. What's my find? The distance from N to Q. So let me see here. What's a relationship I can use? What's the midpoint? So that tells me that these guys are equal to each other. They're congruent. So I can say that the distance from N to Q is equal to the distance from Q to T. And now I'm going to substitute this here and this here. I'm going to go ahead and add 4x's to both sides to undo the minus 4x's. And then I'll take away 3 from both sides to undo the plus 3. And then I'll divide both sides by 6 to undo the times 6. So x is going to be equal to 1/2. Where did I get 1/2 from? I reduced 3 over 6 to 1/2. And if you box your answer here, you're actually wrong. Why? Look what you're trying to find. Don't forget that. So let's go ahead and figure out what NQ is. NQ is this piece here. which is equal to 2x plus 3. So let's take what we found for x and substitute it on n. 2 times, this is 1/2. Now keep in mind that's 2 over 1, so if you multiply straight across, you get 2 over 2, which is really 1. So NQ, the distance from N to Q is really 4. And now that's what I was really looking for. So now you're done. Number 1, make sure to find what you're really looking for. And number 2, sketch a picture if you don't have one. And number 3, make sure you mark that picture up and annotate it. And number 4, come up with the relationship and get the algebra in there, and you're good to go. Good luck.